Okay, so more from section 4.3. This is about graphing log functions. Okay, and our first example is going to be graphing by plotting points. All right, and so we're going to graph f of x equals log base 2 of x. So we want to choose some x values that we're going to be able to easily evaluate the log base 2 of. Okay. So we can't look at any negative numbers because you can't take the log of a negative number. And you can't take the log of 0 because 2 to a power will never equal 0. Okay, so I'm going to think about some powers of 2. So perhaps 1/2. So log base 2 of 1/2 means 2 to a power is 1/2. And that's the -1 power. Okay, another power of 2 would be 1. Okay, 2 to the 0 power is 1. So log base 2 of 1 is 0. Another power of 2 would be 2. Whenever you have a base and something that you're taking the log of and they're the same, it's always equal to 1 because log 2 to the first power is 2. Okay, and then I could take log base 2 of 4. 2 to the second power is 4. So let's look at the points we have so far. So 1/2 is -1. 1, 0. 2, 1. And 4, 2. Okay, and the graph is going to look, oh, that's terrible. The graph is going to look kind of like this. Okay, and as we get closer to 0, we're going to get closer and closer to infinity. So we have a vertical asymptote at 0, and you can never take the log of a negative. Okay, so the domain of this graph and the domain of the function is 0 to infinity. Okay, whereas the range is all reals. Oops. Okay, and the other thing I want you to remember is that log is the inverse function of the exponential function. Okay, so if you think of 2 to the x power, all right, that's going to be the inverse function of log base 2 of x, meaning that all the x and y's are reversed. Right? If I graph 2 to the x instead of 1, 0, I would get 0, 1. All right, 2 to the -1 power is 1/2. And 2 to the first power is 2. And 2 squared is 4. So the other way to graph it is to think about the fact that it's the inverse function of 2 to the x, and inverse functions are reflected over the line y equals x. Okay, so this is one of our parent functions right here in blue. Okay, and we're going to use that to do a few transformations. Okay, so g of x equals negative log base 2 to the x. Okay, so the negative is going to be a reflection over the x-axis. Okay, so if you think about the graph we just drew, it went through 1, 0. That point won't change. Okay, our graph went through 1/2 -1. Now our graph's going to go through 1/2 +1. Our parent graph went through 2, 1. Now it's going to go through to -1. Our graph went through 4, 2. It's now going to go through 4, -2. Okay, so 1/2, 1. 1, 0 doesn't change. 2, -1, and 4, -2. So all of our y values, oops, have opposite sign. Okay, now this is a reflection over the y-axis. Let's use a different color. Reflect. Dear. Okay, so same story. We're still going to think about our parent function. Okay, let me just put our parent function here in red. Maybe that would be useful. Okay, so this one is log base 2 of x. This one is negative log base 2 of x. All right, and this one is going to be log base 2 of negative x. So instead of going through 1/2 -1, it's going to go through -1/2 -1. Okay, instead of going through 1, 0, it's going to go through -1, 0. And then we're going to have -2, 1 and -4, 2. And so there is our graph, log base 2 of negative x. Okay, and this graph is only going to exist where x values are negative. Okay, you need that negative sign to cancel out in order to be able to take the log of it. Okay, and then this is just a drawing of a bunch of parent functions. So it looks a lot like when we looked at all of the different exponential functions. These are just all the different log functions. So note, they all go through the point, oh dear, the point 1, 0, right? Just like all our exponential functions went through 0, 1, and this is the inverse. Okay, and then when you go up to the y value of 1, you find that log base 2 of 1, I'm sorry, log base 2 of 2 is 1. Log base 3 of 3 is 1. Log base 5 of 5 is 1, and so on and so on. Okay, and when we're in the fractions, we would be below the x-axis, right? Because the log of any fraction would be a negative. All right, so those are all your parent functions. All right, and here are some more where we're using the parent functions we just looked at to sketch the graph. All right, so g of x is 2 plus log base 5 of x. Okay, so 2 is a shift up. Okay, so we'll start at the point 1, 0. That's on every parent function, and we're going to move that up 2. All right, so the log base 5 of 5 should be 1. We're going to move that up 2. Oops. Dear. All right, and then we'll think about 1/5. 1/5, log base 5 of 1/5 would be at -1. We add 2 to that. We'll be right here. I drew that a little close. It doesn't actually touch the axis, right? We still have our asymptote on the y-axis, so it gets very close, but doesn't actually make it to 0. Okay, and then h of x, log base 10, oops, log base 10 of x minus 3. Right, so I don't think I'm going to have room to fit this on the graph. Now that I look at it, let's change it. Let's change it to plus. Why am I changing it to plus? Well, because 10 is going to be way off the charts, and if we had a +3, we would be even further off the charts here. So let's instead make it a shift to the left. All right, we're changing our x values by 3. All right, so every parent function goes through 1, 0. So we're going to shift it 1, 2, 3. Okay, log base 10 of 1/10 would be at -1. And we're going to go back 1, 2, 3. And then log base 10 of 10 would be at 1, which is way over here. And luckily we get to go back 3. We'll be at 7. So we'll just make it. All right, and since we've shifted left, that means our asymptote is now at -3 instead of 0. Okay, so we can't go further to the left because we can't take the log of a negative. Oh dear, I clearly went over. Oh. Well, I'm sure your drawings will be much lovelier than mine, but it looks kind of like this. All right, and if we look back at the parent function, the purple is log base 10 of x, and while mine isn't as beautiful, it does have a similar shape. Okay, so it's a lot flatter than some of the log functions. It flattens out more quickly. Okay, and that's how you graph transformations of x.